Welcome to another Mr. Paul video. Today we're describing functions. We're trying to describe them as either being a function or being not a function. I should have said describing relationships, but we're going to be more describing functions, as in we can describe them as a function. So first, let's start off with the definition of a function. A function is a relationship where every input, namely the x's, have exactly one output, namely y's. So we learned this yesterday, that a function is a relationship where every input has exactly one output. And we used Venn diagrams to describe this. So just to recap what we did yesterday, we had a Venn diagram of a function. And we had a Venn diagram of non-functions, right? Not a function. And the Venn diagram was basically a way of saying, okay, here's a list of numbers, and we'll call these inputs. And then we have a list of numbers, and we'll call these outputs. These are outputs. And basically, if I have a list of inputs, let's just say it's 3, 5, 15, -3. And then on the outputs, let's say I have 6, 2, 20, 26. The numbers are irrelevant. I have no idea why I came up with these numbers. What's only important is the mapping. Does 3 go to one unique number, say 6? Does 5 go to a unique number, say 26? Does 15 go to a unique number, say 2? Does 3 go to a unique number, say 20? There's never a time when I put in a 3 and something besides a 6 comes out. Compare this to the non-function. We have a list of numbers, and we're going to use different numbers than that side this time. Let's just say we have a 1, a -2, a 6, and a 15. I used 15 over there. Let's choose something else. -7. And on this side, I have 8, 21, -1, and 0. I don't care how these numbers became these numbers. That's not my goal for today. I wanted to describe whether it's a function. To be able to do that, I need to understand the mapping. When I put in a 1, only an 8 came out. When I put in a 2, a 0 came out. When I put in a 6, 21 came out. But there's a problem with the numbers -7. I put in -7, -1 came out, and -8 came out. I want you to focus on the -7 produced both 8, and it also produced 0. This is the reason why it is not a function. When I put a -7 into my machine, into my function machine, it produced 2 separate outputs, meaning 2 different numbers from my output list. These are my inputs. One input produced 2 outputs, and I could tell it did by these arrows that are telling me. Yesterday, we also described these as ordered pairs and as tables. So let's go back to the tables idea. We have examples of functions and things that are not functions. So an example of a table that would be a function, we have a relationship between x and y where we have some numbers. Let's just say we have the number 1, the number 3, the number 2, and the number -2. 1 produced a 4, 3 produced a 1, 2 produced a -2, and the -2 produced -4. I made those numbers up. They're irrelevant. An example of a non-function would be x and y. We have 1 and we have so much space here. 1 produced a 4, just like it did before. 3 produced a 1. 2 produced a -2. And instead of writing -2 here, I want to reuse +2 again. And I'm going to reuse +2 for a very specific reason. This will still produce -4. I want this to be a non-function, so I want there to be these are 2 separate inputs, producing 2 separate outputs. This is the same input, 2 and 2, producing 2 separate outputs, meaning -2 and -4. The point of today's lesson, this is from yesterday, the point of today's lesson is to be able to quickly identify a function from a graph. So let me quickly graph these. Okay, we're going to quick sketch a graph here. There's my y-axis, my x-axis, and I have some little markers here to let me know where I'm at on my graph. And then I'll produce another graph over here. Okay, now what I want to do is to be able to graph the values in the table and see what they look like graphically. So if I was to take, remember, these are x's, these are y's. And these are x's, these are y's, which means that these are my phone went off in the middle of a video. Okay, so x's are my outputs. Sorry, x's are my inputs, and my y's are my outputs. So to be able to graph these, I'm looking at when x is 1, y is 4. So I'm counting 1 over on the x, and then I'm counting up 4 on my y. So 1, 2, 3, 4. That would represent this relationship. So when x is 3, y is 1. When x is 2, y is -2. And then when x is -2, y is -4. So somewhere down here. Okay? Let me make sure that's a little bit clearer right there. Now, let's compare that to the graph of non-functions. Okay? Everything is the same minus these last two. So when x was 1, y was 4, so we still have the same point that we had similar there. When x was 3, y was 1. X was 3, y was 1. That's the same point that we had over there. When x was 2, y was -2. When x is 2, y is -2, so that's the same point. However, when x was 2, we also had x was -4. So when x is 2, y is -4. Now there's a difference between these two graphs. We have this point here, which was -2, -4. And then we have +2, -4, right? The only difference was this part of the table. But what does that change for us graphically? Well, today we're going to be implementing an idea called a vertical line test. This is a vertical line test. I'll often call it the VLT, the vertical line test. And what that basically means is we're going to imagine that we have a line. We're going to say this ruler represents a line. This is an example of a horizontal line, right? Like looking off on the horizon, right? When you ever been to the beach, this is a horizontal line. A vertical line is a line that goes like this. So what we're going to be doing is using a vertical line to implement a test. And the test is very simple. So I'm not going to use this giant ruler because it's really hard to use. I'm going to be using a smaller ruler. Let me go get it. I'm going to be using a smaller ruler because my graphs are a lot smaller. So I'm going to use this ruler to be my vertical line. So what we're going to do is we're going to imagine that there's a vertical line on this graph anywhere I want. So it could be way over here, it could be here, it could be here, it could be here, it could be here. It doesn't matter. What I'm looking for is if I place my ruler down in any location, I'm looking to see if it touches my points once, twice, 3 times, 5 times. To be considered a function, it can only touch once. So what I mean by that, let's just say I put my ruler down here. You'll notice that I only touch the line at this one specific location. Okay? That means that my input, or the ruler is representing all of my inputs at -2. And I only have one output. When I scoop my ruler over to here, I have one input, meaning at the 1, and it's only producing one output. It's only touching the ruler at one place. If I move it over a little bit further, it's only touching the ruler at one place. If I move it over again, it's only touching the ruler at one place. When I put my vertical line down, it's an imaginary line, it's not part of the graph. When I put it down, and no matter where I put it, it only produces one. It only touches the line once. It only touches my imaginary line once. It's considered a function. So how does it compare to this? Well, if I put it here, sure, it only touches once when I put it on 1. But when I move it over to 2, you'll notice that it's touching 2 separate places, meaning right here and here. Just to show you again, when I put my ruler down, it shows that it touches twice when I have a vertical line right over the x is equal to 2. It doesn't matter how many times it touches only once. I'm looking for the time that it fails. If no matter where you put your vertical line, it only touches once, it passes the test. If it passes the test, that means it's a function. If it fails the test, that means it is not a function. When you place a vertical line down, what you're looking for is if it touches the line more than once. That's what you're looking for. If it touches more than once, you know there's more than one output for every input. Now this may seem confusing, so in this video, I'm going to be showing you a number of examples. So pause your video, copy down the material, and I'll be showing you a few examples. And once you understand it, it'll make your life identifying functions very easy. Okay. So we're going to erase this. And I'm going to draw a couple of quick sketch graphs, and we're going to determine whether they are functions or whether they're not functions. So let's just take, for example, something that looks like this. I'm not even going to draw tick marks on it this time. So there's one graph. Here's 2. Here's 3. Here's 4. We're going to do 4 different examples. We're trying to figure out whether a line is a function or whether it's a not function. So let's just say I have a line that goes like this. And I'll have another line that goes like this. I'll have another line that goes like this. And I'll have another line that goes like this. We can all agree that this one is probably the nicest of the graphs. This one definitely looks weird. This one looks weird, and that one looks absolutely nuts. But we only want to know whether it is a function or not. So we're going to use our vertical line test, meaning our little mini ruler, to decide whether these are functions or whether they are not functions. So I'm going to check my vertical line test. I'm going to place a vertical line anywhere and everywhere on this graph. It's a vertical line. It has to be straight up and down. So I'm going to put it anywhere I want on this line. If no matter where I put it, it only touches this blue line once. No matter where I put it, it passes. Okay? This passes the test. Therefore, this is an example of a function. because no matter where I put it, it only touches once. Compare that with this. If I decide to move my ruler over this section of the graph, if I leave it right there, sure, it's only going to touch once at the point. That's great, that's a success. However, if I move it over to here, you'll notice that I touch here and here. Because my vertical line passes through 2 points on this graph, this fails. Therefore, it is not a function. Because it failed my vertical line test. Remember, it can only touch the line once. Go ahead and pause the video and see if you can identify whether these next two lines are functions or not functions. Thank you for pausing the video. I hope you decided to try. Let's take a look at this one, for example. If I put my ruler here, how many times does it touch that graph? If I put my line here, how many times does it touch it? If I put my line here, as crazy as this looks, no matter where I put my vertical line, it's only going to touch the graph once. This is an example of a pass. Therefore, this is a function. Compare this with this graph. If I put my line here, it touches the graph here and here with this vertical line. Therefore, this one's a fail. This is not a function. This is all made possible by the vertical line test. Vertical line test. I hope this video helps you quickly decide whether a line on a graph is a function or not. That's all for today's video. Peace.